This is my second lecture on chemical in thermodynamics. Last class we have seen the basics of thermodynamics. Okay, what is laws of thermodynamics? What is state function? What is path function? What is energy, etc. Now today we are going to continue to deal with some more basic properties of thermodynamics. Some more definitions. Now, first definition I am going to take is intensive and extensive property. Intensive and extensive property. Extensive property. Now, extensive property is one which depends on the quantity of matter. So, extensive property depends on the quantity of matter. For example, when we say energy is so much, so many kilojoules, then the question is what is the amount of mass involved? So, whenever you have to specify the energy is so many kilojoules for 10 kg of mass. The volume is so many meter cube for 15 kg of mass. So, whenever you have to specify the mass, it's called extensive property. When you don't have to specify the mass, it's called intensive property. For example, if I take specific volume is we give by meter cube per kg. So here already the mass is specified. So we not have to specify the mass. So here the specific volume does not depend on the mass because already mass is specified. Similarly, if we take enthalpy or energy, so many kilojoules per kg. Here again, kg is specified. Therefore, all specific properties are intensive properties, whereas the other things which depend on the mass is called an extensive property. Intensive and extensive property. Now, next we'll take up what is called as reversible and irreversible process. Reversible and irreversible. For example, for any process, we want to know what's the maximum possible. Okay, what's the maximum possible? For example, your marks is 100 out of 100. So 100 is the maximum. So you get 100 out of 100 means that's best marks. 50 out of 100 means is 50%. Like that, we want to specify what is the maximum possible. For a process requires work. What's the minimum amount of work required? Now, producing process, what's the maximum amount of work that can be produced? This can be defined by a reversible process. Reversible process is a process wherein we can attain the maximum in any process. Maximum possible. Now I'll try to explain to you a reversible process. I'll take an example of piston and cylinder arrangement. Here there is 10 kg weight. The pressure is P, temperature is T, volume is V. So, and mass of gas is say 1 kg. So, in the piston and cylinder arrangement, we have got gas whose mass is 1 kg, pressure is P in Newton per meter square, T is the temperature in degree Kelvin, V is the volume in meter cube per kg. Now, on this piston, I got 10 kg weight. Now, the piston is stationary. That means there is equilibrium between this and this. Okay. Now, what I do is suddenly remove this 10 kg. I'll suddenly remove this 10 kg. What will happen is this piston will come to a new position. Like this. Okay. Now, the pressure is P2, T2 and V2. I'll put this as P1, T1 and V1. So, initial pressure is P1, T1 and V1 and the final pressure is P2, P2 and T2. Mass is same. The mass is same. Now, suppose I plot this on a graph. P versus V. Okay, P versus V. Initial pressure. This is P1 and V1. The final pressure is here P2 and V2. So initial value we know P1, V1. Final value we know P2, T2. In between, we don't know. Is the process like this? Or is it going to go like this? Or like this? We don't know. So between P1, V1 and P2, V2, we know initial state and final state. In between, we don't know. Now what I'm going to do next is, come back to this. I'll put 10 kg once again here, divided into 2, 5 and 5. So what I do now first is, I remove 5 kg. Remove 5 kg. It will come some intermediate value like this. So I removed just 5 kg. Then the next step, I remove the remaining 5 kg. Okay, this is final value P2, V2, T2. This is intermediate value, I'll call it P3, V3, T3. Now let me plot this on a graph. Once again, P versus V. This is P1, V1. This is P2, V2. This is P3, V3. Here again, between 1 and 3, I don't know how it is going. Is it going like this or like this? I don't know. Similarly, here to here, I don't know. But compared to the first case, that's some information. We've got some intermediate point. Okay? Therefore, let me do one thing. That's what initially it was a single stage process. Now it is a two-stage process. P1, T1 to P3, V3, then P2, V2 back. Now let's take the last example, last case. What I'm going to do is, I'm going to divide this 10 kg into 1 gram like this. So I'm going to divide this 10 kg into 1 gram each. And at each time I remove 1 gram. The next time 1 gram. Next time 1 gram. Till I reach the final value. Okay? What is the final thing? Final thing is P2, V2. P2, V2, T2. So I am doing 1 gram at a time slowly. What happens? Piston moves up very, very slowly. Okay? Now, if I plot this now on the graph, P versus V. This is P1, T1, initial value, P1. Final value is P2, V2. But in between, what happens is, like I know the values, small values like this. I am doing 1 milligram like this. 1 gram. So what you see here is pressure and volume, or when you have a continuous relation between pressure and volume. So I can draw a graph now easily. So by removing 1 gram, the process is very, very slow. But at any point of time, the pressure between the system and the surroundings is almost equal. Therefore, this is a continuous process. Pressure is related to volume continuously. It is P is related, PV is continuous relation. Continuous relation. Now, this process is very, very slow, but we have got information between 1 to 2. I can now find out the work under this curve as W equal to integral P dV. So, area under this curve, integration can be used only for continuous function. Pressure and volume are continuous functions here. For every value of pressure, there is a corresponding value of volume. Therefore, pressure and volume are continuous functions. And integration can be done only for continuous function. W equal to P dV. Or now I can also have volume like this. I can also have a area like this. I'll remove this. I can also have areas like this. Now this work is given by, I'll call it WS VdP. This area now is called VdP. Now this is a work in a continuous open system. We'll see later. This is a work in an open system. This is work in a closed system. This is work in an open system. This is a work in a closed system. Now we see this process, which is very, very slow. But at any point of time, there is relation between the pressure and volume. Therefore, it's called a reversible process. Reversible process. Reversible process. Now, let's come back to this equation. W equal to integral P dV. W equal to integral P dV. And Ws is equal to integral V dP. Now, let me assume, for ideal gas, PV equal to RT, okay, or P equal to RT by V. Now, let's take this first equation. We assume T is constant for our analysis. To make things simple, I'll assume T is constant. It's isothermal process. So, W equal to integral RT dV by V, that is, and integration limit is V1 to V2. If you integrate this, you will get as RT log V2 by V1. This is the work in a closed system, okay, at a constant temperature. But let's take this equation, second equation. Ws is equal to integral V dP. What is V? RT by P. RT by P into dP. Here again, if you assume temperature is constant, you will get RT, where limits are P1 to P2, and you will get it as RT log P2 by P1. Okay, RT log P2 by P1. Now, we know P1 V1 by T1 is equal to P2 V2 by T2. Now, you assume temperature is constant, therefore T1 equal to T2. They will get cancelled. Therefore, P2 by P1 is equal to P2 by P1 is equal to V1 by V2. V1 by V2. Now, substitute here P2 by V1 by V2. We will get it as Ws is equal to RT log P2 by P1. That's equal to RT log V1 by V2. Okay? Or it is minus RT log V2 by V1. Okay? RT log minus V2 by V1. So this is work in an open system, this is work in a closed system. See the difference here. This is a minus here, this is a plus there. This is the difference between open system and closed system. Now this reversible process gives you the maximum amount of work that can be obtained in a work producing process, and the minimum amount of work required in a work requiring process. For example, compressor, you have to put in work. Therefore, we can find out there is a minimum amount of work required in the reversible process. A generator produces work. Therefore, if it's a reversible process, the maximum amount of work it can produce. So this is a concept of reversible, irreversible process. What is the property of a reversible process? Reversible process is a stage-wise process, extremely slow process, extremely slow. But at any point of time, the difference between the pressure in the gas cylinder, this cylinder, and this, if this is P minus delta P, a very small difference. Okay, so it moves. Suppose I make this as P plus delta P, then it will move in this direction. If it's P minus delta P, it will move in this direction. If P plus delta P, it moves this. So a small change in pressure change the direction of the process. Therefore, it's also called almost the pressure here and pressure is almost same. Therefore, it's also called equilibrium process. Equilibrium process. It's also called equilibrium process. Now, having said equilibrium, what is equilibrium? Equilibrium. Equilibrium, for any process, rate is equal to driving force by resistance. Now, for equilibrium process, rate is 0. Equilibrium process, rate is equal to 0. It's an equilibrium process. It can be rate or net rate. Net rate. Okay, equilibrium net rate. So, for example, you take A plus B giving C plus D. If the rate of A plus B in this direction and rate of C plus D both are same, that means forward rate and backward rate is same. That means in this case net rate will be equal to 0. So for equilibrium process, rate should be equal to 0 or net rate equal to 0. Now look at this equation. Rate can be 0 if driving force is 0 or resistance is infinity. So rate equal to 0 when driving force equal to 0 or resistance is infinity. Resistance. Because 1 by resistance, 1 by infinity is 0. Therefore, a process whose rate is 0 because of driving force is 0 is called true equilibrium. True equilibrium. A process where the rate is 0 because resistance is very high is called false equilibrium. False equilibrium. For example, you take hydrogen and oxygen. They react. Hydrogen and oxygen, H2 plus half O2, giving you H2O. Normally, they don't react. But if you put a spark here, electric spark, immediate water is formed. That means initially, when hydrogen and oxygen are combined, it is there, nothing is happening. It's under false equilibrium. So we have to give a spark, that means we are producing some energy. Okay, so to initiate the reaction. Therefore, though it looks like equilibrium, when you have to put a spark there, the equilibrium is disturbed and hydrogen and oxygen gives water. Therefore, this is the case of false equilibrium. Now, having said all this, let me go completing this chapter or introduction chapter. Let me ask you a few questions. I've got a beaker, water. I put sodium chloride. What happens if I put sodium chloride in water? We'll get sodium ions plus chloride ions. The question is, can I say that sodium ions is my system? Is my system. Can I say that sodium ions is my system? Or chloride ion is my system? So if you take this beaker of water, you have sodium ions, chloride ions, sodium ions, chloride ions like this. So they will be randomly distributed. The answer is sodium ion cannot be defined as a system because random, you can't give a boundary. See, if you want to define a system, you have to define the boundary of the system. If the boundary of the system is not defined, then it's no point. However, if I keep an electrode here, a positive and negative electrode, what will happen is all my sodium ions will come outside, all my chloride ions will go to the other side. Now I can say sodium ions is my system because I got a area here, a confined region of space. This is my space defined. So I can define the space. Therefore, it's called, you can define sodium ion or chloride as a system. So we have, what's the definition of system? It's confined region of space. It is enclosed by a boundary. Therefore, a boundary is very, very important. Next question and the last question is, suppose you've got a balloon. I put a pin and puncture it. What happens? It will burst immediately. Is it a reversible process or irreversible process? It's an irreversible process because it's not going slowly. Suddenly it punctures and bursts away. It can't reverse back to original position. Therefore, it's an irreversible process. Irreversible process. So I have now told you about all the basics of the fundamentals of thermodynamics. Next class onward we'll go in for the first law of thermodynamics for open and closed system. If you've got any doubts or anything you want clarification, you can always ask me in my WhatsApp number which I have given you. Okay then, thank you. We'll meet tomorrow.